Howdy everybody, welcome to class. Today we are going to talk about engine short blocks and the rotating assemblies inside of them. What's included in the engine short block? Well, in the previous engine videos, I talked a little bit about the difference between a short block and a long block. So if you remember correctly, our short block is everything that is in our actual engine block, including the rotating assembly with our pistons, rods, crankshaft, pretty much from what the top of the block is, which we will talk about in a few slides here, but that's our deck surface. Anything from the deck surface of our block below is in our short block. So this is going to include the block itself. It's going to include our crankshaft, aka our bicycle pedals, right? Our connecting rods, please don't say con rod, pistons, sometimes the camshaft on OHV or overhead valve style engines. Not many people still use that design. GM is one of the few manufacturers that still uses an overhead valve design. In the picture I gave you guys on Canvas, it actually shows an overhead valve style short block. So if you look in the center, we've got sort of this hole. There's actually a whole line of those holes that is meant to hold our camshaft. Now it's going to include other components involved to transfer movement from our camshaft up into our cylinder heads, but we'll get into that when we get into a cylinder head video. Just know that the majority of modern short blocks do not contain a camshaft. Only OHV style engines. All the rest, which are generally OHC or overhead cam engines, means we're going to have our camshafts in the cylinder head, not in the short block. So that's why I said on OHV. Timing, chain, and gears, again on OHV engines, I'm going to always, on all engines, I'm always going to have my crank gear down at the bottom where my crankshaft is. But if it's an OHV engine, I'm also going to have a cam gear that's also very close up above our crank gear. If it's an OHC engine, the the cam gear is going to be up in the cylinder head, not on the short block. And then I just can't reiterate enough, no cylinder heads are included in a short block. So if you're buying a short block, you're simply buying the bottom half of an engine. Now, what about the engine block itself? Let's break it down piece by piece. So this is a block, right? A block is going to be the housing in which we have our cylinders. And in previous videos, we talked about these cylinders because they are the housing in which our pistons move up and down in. And the materials used for blocks can be sort of all over the place. One of the most common materials used today is aluminum or cast aluminum. The reason for this is because it's light. But a lot of other engines might use cast iron. The downfall of cast iron is that it's quite heavy. Cast iron is very strong, but it is very heavy. So in an aluminum block, what most of the time manufacturers will do is they'll make the entire block aluminum, and then so they can maintain the strength of our cylinders, they use cast iron sleeves. There are some manufacturers that don't use cast iron sleeves, but aluminum doesn't handle combustion or the heat the way that cast iron does. So they have to do special coatings like a Lucacil or Nicocil where they will actually specially treat the cylinders to make them strong enough to withstand pressures and heat. But most manufacturers for your everyday vehicles, Honda, Toyota, stuff like that, they're going to use an aluminum block with cast iron sleeves. When you start to get into some of the German manufacturers like Audi, or you start to get into some fancy stuff like Ferrari, they may use an aluminum block with aluminum cylinders that are just simply treated for that. The downfall of that special treatment is that you can't really rebuild them the same way because once the cylinder walls in here get damaged. On this block here, I could just machine these out, call it a day. On an all aluminum block with aluminum cylinders that are specially treated, they cannot be machined unless they are specially treated again afterwards. So just sort of a little tidbit about those. There's two different ways that our cylinders can be cooled. So many of you have heard of the engine's cooling system. You might be familiar with coolant. You may not know what it is, but I think based upon the name, it's fair enough to know that it has something to do with the cooling of our engine. Well, what needs to get cooled in our engine? Why do we even need to cool our engine? Well, of course, we just talked about the 4-stroke cycle in one of our previous videos where there is explosions happening on our power stroke, right? Well, inside of our cylinders, those explosions are producing a lot of heat. There's also some frictional amount of heat that's happening as well in here. So we need to get rid of that heat, take it somewhere else, offload it, come back, pick up more heat, so on and so forth. And that's what our cooling system does. So in order to cool our cylinders, we've got these water jackets, right? So in this deck, this type of deck surface is what we call a wet or open deck system, meaning that our water jackets are accessible from the top of the deck surface. Not all blocks are like this, and this is something to make note because it has to do with the casting process as well, or the cast that block was made in. So if you're not familiar with casting, I'll throw a video in this week's Canvas shell, and I will share a video on the casting process itself. But in a nutshell, we have a mold. We pour molten metal in this mold. We break that mold, and now we have a component that is the shape that we want it to be. Well, when you make a mold for an engine block, there are things inside, like I said, these water jackets that need to also get molded. So this mold is going to be a multi-piece mold, and there's going to be stuff inside. We usually make this out of sand. Or what is sort of like a type of sand material. So then we end up breaking it up afterward, and we're going to pour all that sand out. Well, how we pour the sand out is dependent on the type of deck surface. In an open deck setup, I can simply turn my block upside down, and all that sand that molded our water jackets is going to come right out the top. No big deal. But on a closed deck system that I've given you a picture of here, there's holes where coolant is going to travel to and from the cylinder head end. Same with oil. But those holes aren't going to be able to offload all of that sand from the casting process. So in a closed deck system, you'll notice, or a closed deck block, you'll notice that there's going to be these little plugs in the side of the block. And I don't have them in this block because it's an open deck. Well, these plugs on the side of the block on a closed deck system or a dry deck system, lots of people will call them freeze plugs. So if you've ever heard of freeze plugs, there's sort of this old wives' tale that they're there put inside of or put to close the block off coolant passageways. But the reason why they're there is that when the coolant freezes, it will expand, right? This does happen when coolant freezes, when any liquid freezes. When any liquid freezes, it does expand, which is why if you go to freeze a water bottle, sometimes it'll crack or something like that, right? So with this expansion, that expansion is actually a lot stronger than you might think, and it can actually crack blocks and cylinder heads and stuff like that. So the purpose said of these freeze plugs is so that when the coolant expands because of freezing, it will pop those freeze plugs out and it will expand outward rather than cracking the block. That is untrue. So the proper name for those plugs on the side of the block is actually core plugs. And the reason why they are there has nothing to do with coolant freezing and has everything to do with the casting process. So when I go to pour out all the sand from my casting process, I have somewhere to pour it out from since the deck surface is closed. So they are called core plugs. Yeah, we can still call them freeze plugs. I'll call them freeze plugs, but I know what they're for. They're not for freezing. So you don't necessarily need to be that person in the shop like they're not called freeze plugs. They're called core plugs. Industry still calls them that, just like channel lock or vice grip, right, that I've talked to you guys about. So just know that's what those core plugs are for. Now, I gave you guys a couple of pictures in your presentation where I gave you a picture of an open deck block right next to a closed deck block. And you can see on that closed deck block, we've got core plugs, freeze plugs, whatever you want to call them. And you'll notice that our open deck block does not have any cord plugs or freeze plugs. So clearly that's not the purpose of our freeze plugs, because if that was the case, then all of the blocks would have cord plugs, right? So that just sort of further proves that point. The next thing I want to talk about are the cylinders, the actual cylinders in our block. So if you were to take a much closer look at these cylinders, they're not just a mirror finish. You'd think like, yo, you want those cylinders to be nice and smooth so that when my piston is moving up and down in those cylinders, it's not creating a lot of friction. Yes, but at the same time, there needs to be a pattern, and more specifically, a cross-hatch pattern on those cylinders. That crosshatch I gave you guys a picture of is going to actually help seat your piston rings, which I'll talk about piston rings in a little while, but it's really important that the surface finish of your cylinders has a proper surface finish for whoever machines that block. Long gone are the days of you being really able to bead hone manually your cylinders. Yeah, sure, you can do it, but you are going to reduce the efficiency of your engine. Your rings are not going to seat quite as properly, especially with low tension rings and stuff. So some of that stuff I'm not going to get into. Again, I'll wait for an engine rebuild class. But some other things to know about these cylinders is that we need them to be perfectly straight up and down. The walls need to be parallel perfectly to each other. So there are two things that can happen that take that away from our cylinders while the engine is running. So we can get two problems. One of them is out of round, where our cylinder is no longer a perfect hole, but now it's really more like an egg-shaped or an oval shape type of shape. This happens for, well, one of the main reasons is that our pistons aren't on a universal joint where they can sort of move. However, they only have this back and forth action on our connecting rod. So when they are turning up and down on our bicycle pedals, we do have two areas sort of on this side and this side where our piston is going to wear further on this side and not so much on this side and this side. This can cause out of round over a period of time, which is why a lot of the time when you go to rebuild an engine, you're going to want to get it at least honed if it doesn't need to be bored, because we want to make sure that our cylinder is perfectly round again before we, put any new components in it. The other problem that we can get is what we call taper. So a lot of you are already probably familiar with this term in general. If anything's tapered, it's generally larger on one end and smaller on another, just like a cup, right? A cup is tapered. It's wider on the mouth generally than it is at the base. You know that we have an explosion that happens on the upper part of our cylinder, right? That explosion happens up here, not necessarily down in the bottom of the cylinder. So that heat and that pressure causes an expansion of the upper part of the cylinder, but not on the bottom part of the cylinder. So we get this taper situation where I have too much space on the top of my cylinder while the space on the bottom is just fine. And so a lot of times we'll have to machine that out again so our cylinder walls are nice and straight. So those are two things that we look at. Again, more stuff we'll get into in an engine repair class. And I kind of already talked or touched on the topic of cross-hatching being critical for your sealing and rotation of your piston rings, which we'll talk more about piston rings in a few slides here. Your pistons themselves have sort of an anatomy themselves. So your piston has a body, which is going to be exactly what you sort of think. It's sort of this middle portion of our piston where it is the body, right? And just like you might think, just like you, it has a head. The top portion of our piston is a head. Sometimes people call it a dome, especially if it's a domed style piston where it's raised up. Sometimes the book might call it a crown. So the upper portion of the piston has a couple of names that I gave you guys in the presentation. If I move my head there, you guys could probably see head, dome, and crown. And then you can see it says ring, lands, and grooves. So your piston cannot be the exact size of the cylinder. And the reason for that is if I made it the exact size of the cylinder so I can slide it in while the engine is cold, what's going to happen when it heats up? It's going to expand and seize inside of my cylinder. So we don't want that to happen. So we make our piston smaller than the cylinder, and in order for it to seal, I'm going to use piston rings that go on my piston that sort of protrude out of my piston that are going to create a seal as it moves up and down to seal combustion and pressure up here while keeping oil and such down here to where we're not getting oil up here. So we've got a couple of different rings for that. And I've actually got a piston that has rings on it so you guys can see a little bit closer. So this piston you guys can see has sort of these rings that protrude out of it. Where those rings sit are called our ring grooves. So back to our piston without it, you guys can see here, those grooves are called ring grooves. And I've got 3 of them on 4-stroke cycle engine pistons. We've got 2 top rings and 1 larger, or 2 top ring grooves that are smaller and 1 lower, larger ring groove. Now these parts that are flush with the rest of the piston that sort of stick out past the ring groove, those are called our ring lands. So we got ring lands and ring grooves. Hopefully that makes sense. Now there's a couple of other parts of the anatomy here. You'll notice that I've got shorter parts of the piston and a longer part on each side here. Those longer parts, those are called our piston skirts. Some pistons have longer skirts, some pistons have shorter skirts, some pistons have no skirts at all. With that, lastly, we got this gigantic hole in our piston. What's that for? So that hole in our piston is to connect our piston to a connecting rod. So our connecting rod is going to go into the piston, and I'm going to put a pin through the center. This is called a piston pin or a wrist pin. And when everything is put together, I'm going to have them pressed in, or I'm going to have little locks or clips that hold that pin in. And when they are put together, you can see it looks something like that. So you can see my rod sliding up and down on that piston pin there. That's going to connect my piston. Now this needs to be able to move freely, so when my leg is moving my bicycle pedals, I can have that sort of motion. So that's just in a nutshell a little bit of the anatomy of our pistons here. Our pistons can be made of different material. I'm not going to get super deep into all the types of material, but 2 common ones are going to be cast and forged. They can be made of different types of metal. Cast pistons are exactly the same process that I was talking about with the block, where I've got a mold, I pour molten metal in that mold, and now I've got a piece once it cools down. Forged, or the forging process, which again I'll sort of throw in a video here this week so you guys can see the forging process. Forging, if you think of sort of back in the old Renaissance days where, you know, if you're a blacksmith, if you think of forging, you think of somebody hammering, pounding on a piece of metal, right? That's what we're doing in a sense, except we're not doing it manually. You're doing it with a big old machine that's like a stamp. And so you're going to take this hardened metal, and you're going to, this block of metal, and you're going to take a big stamp, and instead of saying a mold and pouring molten metal into a mold, you're already taking this piece of metal and you're stamping it into place. So you're stamping a piston into the shape that it is. Now, obviously, certain things like the ring grooves are going to get machined out later, but the overall shape of the piston is actually pounded into shape rather than molded. So the difference between that is going to be a cast piston. Anything cast is always going to be a touch more brittle because of the process. Forging is a much stronger way to create a piece of metal because you have pounded the molecules together. So the molecules are actually in the material are actually much tighter together, which makes it a lot stronger. So forged pistons are going to be used for high pressure situations like turbocharging or supercharging, stuff like that. where naturally aspirated stuff may not require that type of material. And it is a more expensive process, so that's something that you are definitely going to pay for when you go to buy a set of forged pistons. So those are two common types. The piston's job is to act like a plug in the cylinder as it's moving up and down. It's plugging our top portion from our bottom portion. Our bottom portion is going to have a lot of lubrication floating around. Our top portion is meant for compression, combustion, all that good stuff. So that's the job of our piston. Now the design of our piston, and I'll grab a couple different here so you guys can see, is going to determine our compression ratio. Now this one's actually damaged, which is probably why it's here. It's got a big old fat hole cut in it. You guys can see this one has sort of pieces cut out. Those are called valve reliefs, but overall it's pretty flat top, right? And in fact, it's not perfectly flat. There's actually a small indent here. Any indentation that's going to go in through the piston is going to lower the compression ratio from stock anyways. If I take a piston that looks like this, it is not flat. We do have a side that's sort of slanted, so instead of having valve reliefs, that might be why we did that, or maybe to achieve a certain compression ratio, or maybe this was because of the combustion chamber design in the cylinder head. I've got another one here that is a little bit domed, but it sort of has this indentation up on the top. Again, this design or any piston top design is simply to manipulate combustion when it happens. So we are either going to try to increase our compression ratio, how much we're squeezing that air-fuel mixture, or decrease it depending on what it is that you want to do. It also is going to accommodate for the shape of the cylinder head or the valves protruding out of the cylinder head. So a lot of those things go into consideration when they're designing piston head designs or crown designs or dome designs. Now the piston rings themselves, I already showed you, this one has rings on them. So if we look a little closer, we've got these two top rings, and down here we've got like these really funky looking rings. So these two top rings here are what we call compression rings. The job of our compression rings is exactly what it might sound like. It is to seal the piston from top to bottom and seal my compression on top, as well as my combustion. Down at the bottom, if we take a closer look, those oil rings down at the bottom, that weird sort of looking ring right here at the bottom, those are our oil rings. Now, our compression rings, there's only one ring in each groove. The oil rings are different. There's actually 3 rings in one groove. So if I break it down, this would be what a compression ring looks like. And this is a huge dump truck ring. This one's going to create a lot of drag, but it's going to seal really well. But that's an example of a compression ring. Our oil rings have 2 types of rings. So I'm going to have 2 very skinny, what we call, this one's trash, which is again why it's here. You can see if I take a compression ring and I put it next to an oil scraper ring, if I can pick it up here. If I put those 2 side by side, you guys can see this one is insanely thinner than this one. So what we're going to do is, this is a scraper. I have 2 scrapers on the bottom groove. And in the middle, you guys see that weird looking ring? That's something like this. That's called an expander. So the way our oil rings are set up is I've got on top, I've got a scraper, and this is all in the lower groove, one groove. On top, I've got a scraper. In the middle, I've got my expander, and underneath, I've got another scraper. So we've got this sort of sandwich, and I'll sort of give you a closer look here. I'm not using the rings that go together normally, but this is sort of what we got going on. A scraper on top and a scraper on bottom, an expander in the middle. The job of our oil rings is to trap a little bit of oil in there So as the piston moves up, it is bringing oil up on the cylinder walls to help lubricate the piston, but its job is also to take that oil it brought up and to scrape it back down. That way we're not leaving any oil up in the top chamber of our piston and then burning oil. So if you've got an engine that's really worn out and is tossing blue smoke out the back and burning tons of oil, very likely that your oil rings have just gone bad. That's all. And there's not much you can do about it except for rebuild the engine. So those are our compression rings. Those are our oil rings broken down to expander and scraper. When you guys will notice that our rings, most of the time, will have a little gap. The reason why they have that gap is so pretty much I'm able to install these on my pistons. They do make gapless rings. It doesn't mean that it's a full ring. It means that it has an extra piece that's going to overlap here. These ring gaps, that would be more for a performance application. These ring gaps cannot be lined up. So if I've got two compression rings, I can't line those up. I got to make sure and offset them, because if I line them up, now compression can leak past through those rings. So just FYI, all this stuff we're going to spend so much more time in when we get into an engine repair class, engine lower specifically.